Good day, Algebra. We are covering PO51, which now that we've kind of gone through all the operations that we've talked about adding, subtracting, polynomials, multiplying them, dividing them, we're going to look at something called factoring. Okay? And you've dealt with factors before, right? Greatest common factor. We know that factors are the numbers you can multiply to equal the original or the given number. For example, the factors of 12 are 3 and 4, because 3 times 4 is 12, and 6 and 2, and 1 and 12, right? Those are factors because those numbers multiply to give you 12. So what we're looking for today is we're looking to factor trinomial expressions in x squared plus bx plus c equals 0 form, okay? Where the coefficient x squared is a 1, b is a number, c is a number, and we'll talk about why it's equaling 0 when we get to parabolas. But if you remember back to, was it PO48, where we multiplied binomials together? That's what we're looking for. That's what we're defining as the factors of these trinomial expressions. What binomials multiply to give us x squared plus 7x plus 10? Well, the answer is x plus 2 times x plus 5. What binomials multiply to give us x squared plus 12x plus 32? The answer is x plus 4 times x plus 8. What binomials multiply to give us x squared minus 14x plus 45? The answer is x minus 9 and x minus 5. And what I want you to do is I want you to look at those binomial answers and see if you can come up with any connections. See if you can come up with any patterns. Why are the factors of x squared plus 7x plus 10, x plus 2, and x plus 5? What do you notice about that? How do we get x plus 4 and x plus 8 as factors of x squared plus 12x plus 32? Where does x minus 9 and x minus 9 come from as factors of x squared minus 14x plus 45? Anything that stands out to you, anything that seems coincidental or peculiar, or Alex?
Just add the numbers, the 8 plus 4 together to get the 12x.
Okay, so one thing that Alex is noticing here is that something with this positive 4 and this positive 8, he's noticing that 4 plus 8 equals 12, which shows up in our original trinomial. Anything else? Arlene?
When you multiply the 2 and the 5 and the 4 and the 8 and the 9 and the 5, you get the number 11.
Furthermore, again with that 4 and that 8, when you multiply them, 4 times 8, which gives us 32, lo and behold, that's the constant in our original expression. Does that hold for the rest of them?
Yes.
Yeah? Let's look at this one here. 2 plus 5 gives us 7. Where's the 7 in our original trinomial? 7x. Okay. And then 2 times 5, which is 10. Where's the 10 in our original trinomial? Right here. Look at that. Let's do the third one. Ooh, does it work here though?
Yeah.
Why? Damien?
But it's 2 negatives equal 5.
So when we go to our multiplication, negative 9 times negative 5, that does give us positive 45, which is what we have in the original trinomial. Okay. For the addition and the subtraction, a negative 9 and a negative 5, which we can write as negative 9 minus 5, gives us what? Negative 14, which we have in the original trinomial as well. So there's definitely a connection there between the numbers in our binomials and the terms in our original expression. And of course, you can check this answer pretty easily. Does x plus 2 times x plus 5 equal x squared plus 7x plus 10? Well, we can box it here. X squared, 2x, 5x, 10. Put them together, and that's exactly what we end up with. You can FOIL, crab claw, whatever you want to do. So checking your answer for these is very easy. Just whatever factors you get, multiply them, and do they equal the original expression? Lisa?
You can also add both of the x, or multiply both of the x's on the
Yes, all of these start with x squared. This is the form that we're working with here, okay? And so all of your answers, your binomials will each start with just an x, because that's where that x squared comes from. You're absolutely right. Elliot. Sorry? So where we're heading with this is to parabolas. And if you're not unfamiliar with what a parabola looks like, we've talked about before. What's a parabola shape? Yeah, it's either a smiley face or a frowny face, right? And when we start to graph parabolas, okay, if I stick a coordinate plane in here, how many places does that parabola, that top one there, touch the x-axis? Twice. And so where we're heading with this is the equation for a parabola. You know, slope-intercept form is for a straight line. This is for a parabola. It equals 0 because where we're going is we're going to use these to solve for the x-intercepts of parabolas, essentially. Okay? I was getting you used to seeing it equal to 0, so it's not a shock when we get to that point. That's where we're headed. Right? Sometimes your original trinomial will not be in standard form. It's not going to equal 0. And so all you need to do is put it the way you want it to be, right? In math, oftentimes if something isn't written the way you want it, write it the way you want it. And all that requires you to do is to add 9x to both sides here, right? So it equals 0. In standard form, that 9x is going to go between your x squared and your constant term, and now you're in business to factor it. Okay? X squared equals x plus 30. Personally, I like to keep my x squared term positive, because if my x squared term is positive, I know that both these x's will be positive. If x squared is negative, then you kind of got to play with the signs. So in this case, I recommend subtracting x and subtracting 30 to move both terms over to the other side, giving us x squared minus x minus 30. And we're factoring that. Okay? What's the coefficient to that negative x there, even though it's not written? -1, right? Which, when we look at our numbers in our parentheses here, again, I'm giving you the answer. If we add them together, 5 plus -6 or 5 minus 6 does give us -1, so it still holds, right? And then a positive 5 times -6 does give us -30 there, okay? And the last one too, doesn't equal 0, move this 120 over, make sure you put it in the right spot, change the sign, it's now positive, and we can get to work factor, okay? Questions so far? You don't get it? What's your question?
Nothing.
Oh. Do you get it? Oh. What don't you get? Oh. Lisa.
So we're basically just like showing that they both equal.
Well, you're not showing, because now if you go down the page a little bit, you'll see that all of a sudden now I don't give you the answer, right? So now we have to factor them.
Oh.
No. But we're using those connections that we just saw, right? Where does this 11 come from? Well, first of all, let's set up our answer here. We know that our two binomials will each start with an x, because this is the form written with that x squared. The only way to get that is x times x. And what did we say? Where did this 11 come from? Where did this 11 come from? Yeah. Two numbers added together. And where did this 28 come from? Two numbers multiplied together. Right? And of course, whatever numbers that we use for the red and the blue, they have to be the same. So there are lots of numbers we can use to add to make 11, but not so many options for multiplying to be 28. Really, for this 28 one, we're looking at either 1 or 28, 2 or 14, or 4 and 7. Those are the three ways to get to 28. Jack, which one are we going to be using here? Which set of these numbers that multiply to make 28 also add to make 11? I don't think you need to tell them. And he can figure this out himself. Which pair of these numbers can add or subtract to make 11?
4 and 7.
4 and 7. Bingo. Right? You've just cracked the code. You've just factored that trinomial because if 4 and 7 are the numbers that make those two relationships true, they are the numbers that are going to be in your binomials. Okay? X squared minus 9x plus 18. Two sets of binomials, each one having an x. We are looking for two numbers that add to make a negative 9. And those same two numbers multiply to make 18. Raise your hand. Don't shout it out. Raise your hand when you think you have the correct combination. Make sure you are paying attention to signs also. They do matter. Vince. No? Max?
-6 and -3.
Good. -6 plus -3 is -9. -6 times -3 equals positive 18. Therefore, -6 and -3 are going in our parentheses. Okay. Would it make a difference if you put x minus 3 and x minus 6? Do they have to be x minus 6, x minus 3 order? No. Right? Because you can multiply two binomials in any order, you're going to get the same end result. Just like we talked about making the 2x3 box, if you put, the 3x3, doesn't matter which triangle goes up top, which one down the side. Same kind of thing here. You can multiply these two binomials together, either order, right? And you'll still get the original trinomial. Elliot.
I have a question about the one underneath that.
Let's finish these four and then we'll talk about that, okay? All right? Raise your hand if you can give me the combination for this one. We are looking for this relationship, and we are looking for this relationship. Okay? It's supposed to be a 45, right? Now I got to rewrite everything. That eraser is so big. I'm sure there's a way to make it smaller, but I don't know how to do it. And I will say this too. I know just by walking around and looking at binders when I check in homework, some of you are only putting the answers down and none of this middle stuff. Okay? When it comes time to preparing for a test or your next open binder quiz or whatever, it's going to be helpful to have this. How do I get there? Because a week from now, if you look back at it and have no work shown at all, it's tough to see the relationship there. Okay? So don't just write the answer down. Write how we got there too. It's like when you're taking directions down from MapQuest. You don't just write the final direction. You write down all the stuff in the middle also. Yes, I still use MapQuest. What is it?
Yeah, I've never done that.
That used to be the gold standard in how to get directions on how
That's not anymore.
to. Okay, what do we got? Kylie. 15 and -3. 15 plus -3 is 12. 15 times -3 is -45. So positive 15 and -3 are the numbers in our parentheses. Positive 15, -3. Do the last one on your own.
That's the hardest one.
Yes, that is the You told us to write down our work, but that's how to do it.
Yes, but you should still write down the words because it's not going to tell you how to do it on the test or something like that. So
I practiced.
when you should get the habit down of what you need to do.
Did you fail?
Thank you. All right, who's confident they got a solution here? What you got? Beckman.
6 and -1.
6 and -1. 6 plus -1 is 5. 6 times -1 is -6. So x plus 6, x minus 1 are your answers. Okay? Folks, if you're having trouble coming up with these combinations, I recommend you start with the factors because there are only a certain number of options that multiply to give you that constant term. You're only looking at 1 and 6 and 2 and 3, right? There are lots of ways to get positive 5 by adding and subtracting. There's only 2 ways to get 6. So start with that constant, get your options down, and then look at how do I get 5 from these numbers. Now this one was a little bit set up to trap you because 2 and 3 can make 5 as well. However, the signs don't match up if you use 2 and 3, right? The signs don't match up. Okay, questions on those 4? Elliot, you had a question on one down below. What do you want to talk about?
The middle one.
Middle one. Okay.
So it's written as x plus 10 and x plus 10. So can you just write x plus 10 squared?
So I'm going to show the work here. So we're looking for 2 numbers that add to make positive 20. Those same 2 numbers multiply to make 100. Elliot's determined that 10 and 10 are the combination that we're going to use here.
Oh, yeah.
And so he's saying, hey, folks, side conversations, no warning for you. Okay, quiet. He's saying that since these are the same, x plus 10 times x plus 10, could we just write the answer? Should we just write the answer as x plus 10 squared? Okay, and my answer is I don't care. Either way is fine. Okay, x plus 7 times x plus 10 is equal to x plus 10 squared, but you would not have to write it that way if you don't want to. Okay. Any others that you want to talk about here that look like they're worth our time discussing? Alex.
I just have a question.
Yeah.
Let's say if a number is prime, is it possible?
Well, which one are you looking at?
I don't know. 39. No, that one's not. 23.
When you say which number, you're talking about the constant?
Yeah.
Like in this one here?
Yeah.
Yeah. So for this one, we're looking for 2 numbers that add to make 4. And those same 2 numbers multiply to make 3. Now, 3 being prime, it's kind of easy that the only factor pair to work with is 1 and 3. Can you make a 4 out of 1 and 3?
Yep.
Yes. So is it possible?
Yeah.
Yes. Right?
Literally.
1 plus 3 is 4. 1 times 3 is 3. So x plus 1, x plus 3. Okay? Has anyone come across one that they think is not possible? Vince?
The very last one. That's the last
Third
one's
one
so
on
possible.
that one.
Can you read it?
X squared plus 10 plus 16.
Okay, x squared plus 10x plus 16. Okay? Do we agree that that one's not possible?
No.
What's our combination?
8.
8 and 2, right? 2 times 8 is 16. 2 plus 8 is 10. Anyone come across one that is not possible? Because there is one out there.
Oh.
There are several, but there's at least one on the page. Jack?
On the next page.
Yeah?
And the second row, third row.
X squared plus x minus 42?
1.
What do we think? Possible or not possible?
Not possible.
Not possible.
So we're looking for
Everything's possible.
Let's start with the factor pairs of 42. Give me a factor pair of
6 and
42.
7.
6 and 7. That seems to be a potential winner, right?
Yeah.
Jack, can you make a positive 1 out of 6 and 7?
Yeah.
How?
7 minus
7 plus negative 6. Does 7 times negative 6 equal negative 42?
Yep.
So is that one possible?
Yeah.
Yes. Anybody else? Find one that's not possible. Kylie. The last one on the second page? All the way down? Okay. We're looking for two numbers that add to equal negative 18. And those same two numbers multiply to equal negative 63.
I don't think it's possible.
What are some factor pairs of 63?
Anything.
What?
9 and 7.
9 and 7 is not the only factor pair.
What?
9 plus 7.
63 and 1. Okay.
15 and
21 and
21 and 3.
21 and 3.
Never know.
Oh.
I think it's possible. Okay. For many, your success will kind of depend on how well you know factor pairs,
Yeah.
right? And so where the danger here is that you don't list all the potential factor pairs and don't test every option. 3 and 21's the winner because we can make a negative 18, negative 21 plus 3, and negative 21 times 3 is a negative 63. So that one does work out as well. Okay. Damien, you think you found a not possible one?
I think the whatever it's called, fourth row, second one.
Can you just read it?
X2 minus 22x plus 21.
I will tell you that one is possible. Joey,
The second row, second one.
Yeah.
second row, second one. X squared minus 12x equals negative 35.
That one's also possible.
Okay. So, yes, shush, I would agree.
Just let him do it.
We start, of course, what's our first step here before we start to look for possible combos? Alex? Have to move that negative 35 over. Okay.
Oh, that's a third one.
Read the one that you want to talk about.
X squared minus 7x
Okay.
minus 3.
So we are looking at numbers that add to make negative 7. And those same numbers multiply to make negative 30.
No, possible.
Yeah.
Possible. It's possible. Jack, you find one?
Yep.
Which one?
Negative, that's right, it's negative 10.
No, I don't want the answer. I want you to tell me which one is not possible.
Oh!
Jack?
Fourth row, first one.
Read it, please.
X squared plus 6x plus 10 equals 0.
X squared plus 6x plus 10 equals 0. Why do you say that one's not possible, Jack?
Because I just don't think
Let's start with the factors of 10. We've got 1 and 10, and we've got 2 and 5. That's it. Do either of those factor pairs can be combined with addition or subtraction to make 6?
No.
You found one that is not possible.
Yes, sir.
So, when you've got one that is not factorable, it doesn't mean it's not a trinomial, right? It doesn't mean it's not a parabola when we get to that point. All it means is that it is not factorable. Just like if I asked you to factor the number 7, the only combination is 1 and 7, because what type of number is 7? Prime. This would be a prime trinomial. Okay? So if something is not factorable, just like a number, if it's not factorable, it's prime, you can have a prime trinomial as well. And that would be an example of a prime one. Okay? All right, questions only at this point. Alex. Beckman.
What is the top row, third one? How do you do that?
Top row, third one. Okay, so you have to write out all the factor pairs of 60, right? Because our answer has to contain two numbers that multiply to make 60. and those same two numbers add or subtract to make negative 23.
Oh, I thought 23 was
No? Okay. This is going to be homework for tomorrow. Okay. The rest of the objective, you got just under 15 minutes to work. I will be available to answer your questions if you have them. And then we'll move on tomorrow. So that's on that.